Data sets are rarely ever perfect. Almost never. There's always going to be something wrong with them. There's got to be some error that's incorporated into them. And that's something that we live with. And we just accept it and we say, well, what we're going to try to do is find the data that's produced at the highest quality that we can find and use that information preferentially over anything else. And is my data appropriate for what I want to do? Is it done at the right scale? Was it done in such a way that it minimizes the amount of error that's in the data? That's the kind of thing that I'm looking for when I'm doing analysis, and that's what we should all be looking for. Um, the same data set that you've got in your hand may be unsuitable for one use, but perfectly fine for another. So you wind up collecting data sets when you work, and you hang on to some for a while because they're very useful. Some you decide to jettison because you find that it's just not very well done, so we'll get rid of it. Those of us who are the GIS analysts, the GIS technicians, it's our job, ethically and legally, to make sure that the data set that we're using is sufficient for its intended use. We're the ones that are going to be called to question if we're using data that's not appropriate, if we're using data that's not been produced well according to established best practices. If we're just using crap, we're going to be the ones that pay for it in the end. So some of the things we're worried about is the characteristics of the data, geometric accuracy. Does it match as well as it can the data set to the real world? And if it doesn't, if it's filled with too many geometric errors, we probably shouldn't be using it. Okay, when we're comparing data sets, and maybe we have, for example, here, two different roads data sets that are trying to describe a road, which one's going to be correct? Which one was done at a scale where we can accept it's probably superior in terms of accuracy and precision and topology in matching what's actually on the Earth's surface? So another thing we might be interested in our data sets is the thematic accuracy, the level at which the theme of the data matches what the reality is out on the landscape. And in this particular case here, we're looking at tree crown density or crown cover, how the extent to which tree branches are growing into each other and forming a continuous surface of tree branches and needles and leaves covering the ground. How are those things measured? And how accurate was the field team that went out to measure those things? Did they use good procedures? Did they use best practices to minimize the amount of observational error that they might have included in the data? And related to that, then what are sources of error when you're dealing with field measurements? Those are things that we need to be aware of as a GIS analyst and technician. If we're working with people, for example, within a federal agency who may be working in different offices, so there's field folks, there's office folks, you're probably going to be one of the office folks. You may get out in the field every once in a while, but you need to know what the methods are that everyone who's collecting data that brings it back to you and says, here, map this. So you need to know, are they following the best practices in the profession? Are they doing everything that they can to minimize error? And are you getting good information that can then be put into data sets like this? Also, when you obtain data from someone else or some other agency or corporation, are they following best practices? Are they doing what they can to minimize error? You have to be confident about that when you select those data sets and use them in your analysis. Looking at resolution in a couple different ways. it's not just the cell size, but resolution can refer to, in this case, sampling interval of measurements. So how often do you sample your GPS when you're walking a road in order to really describe the curvature and linear nature of the road? Are you getting enough? Okay, does it match well the size of the information you're trying to use in raster information? If we're looking at the resolution for thematic data, again, how fine was how fine of a scale did you use for making your observations? And did something happen to them after you did the measurement? Did you process them in some way, or bring the information together mathematically, statistically, in a way that changed them? Does that still match the observational resolution that you used? Okay. Temporally, here, how often was the data sampled? Was it done daily, monthly, every decade, every 100 years? So we have spatial resolution, thematic resolution, temporal resolution, and there's several other kinds that we can run into in different types of work, especially remote sensing. There's a few more dimensions of resolution that we might access and use. But those are things to be aware of when you're dealing, especially with field crews. How often are they taking their observations? How well are they taking those observations? And then hopefully it all combines together into a grand data set that you can just rely on and use. So precision, as we're using it here, related to GPS measurements, is what this slide is about. The number of significant digits that are within a measurement related to the statistical variability of a repeated measurement. And this is not the same thing as accuracy. What precision is doing is telling us, here on the lower part, we can see. So our GPS unit, we take a single measurement, and it reports locations to the nearest meter. So its precision is 1 meter. If I take 20 GPS measurements at the same location, and I analyze those, and I wind up with a standard deviation of 5 meters, my precision is about plus or minus 10 meters to encompass that standard deviation. So that's what precision is referring to here. We'll see another kind of a definition for that later when we talk about accuracy and precision in more detail in a later chapter. And finally, the last thing here we're going to look at is, again, this word metadata. Metadata is something you need to get familiar with and start reading and accessing through ARC Catalog. ARC Catalog is the tool where you can read the metadata for any of your data sets. And it's going to be filled with all kinds of information, hopefully, by the people who created the data set and who have modified the data set, if they modified it, where they keep track of characteristics about how it was created, when it was created, how often it's been modified, what was done to it if it was modified, if it was the result of calculations, which data sets were used to calculate and create that output data set. So it's something that we'll be using throughout the course, and you will be keeping track of information when you do practicals that can be transformed into metadata. Metadata, I've used the definition before, it's information about information. So it's information that you include with the data set so that whoever uses it can read it and have some confidence in how well this data was created, how well it's been managed over time, and whether or not it's suitable for the use that they intend the data. So anyhow, that's the last slide we're going to deal with on this one. Hopefully we've given you an overview of what GIS is all about, and we're going to get into more details in each subsequent topic or lecture as we go through the course.